Hello everyone, it's September 29th again. Alright, today was all buried in papers, and I was trying to understand what's that thing called Hilbert Schmidt independence criterion. So yeah, I was trying to do that first, and then trying to understand how kernel space can be constructed to compute MMD, and then kernel PCA. Yeah, it's a lot of concepts, a lot of things just swimming around. Man. Right, the skyline problem. It's a tough one. I remember. Oh, look at this. Okay, what else? Timer feature. Alright. Look at this. Yeah, I remember this problem. This is one of the tough ones. Wait, there's no random anymore. I've picked one. That doesn't exist? I mean, I don't see pick one. Test case. Result. Run, debug, console. It's alright. I just have a problem list. Oh, wait, I'll push this. No, it goes back. I want a random feature. Pick one. And pick one here. Alright, anyway. I'll take some time to get used to this. Did they reset everything? Oh. I think discussion is only 7. Did they ever delete all the old discussions? What? Solutions. Something we need to investigate. And what about the add to list? I think I have this list. What's this? Share. It doesn't look like a share. What's this? More actions. Feedback. Alright, let's do this one. Yeah, I remember this one. It's a very tough one. I don't recall how to solve this though. Okay. So we give the geometric, so we know all these rectangles, right? So left to right and height. So on the left, we know the right. So x coordinates, and this is the right x coordinates and height. You may assume all buildings are perfect rectangles. The skyline should be represented as a list of key points sorted by their x coordinates in the form of x1, x2, or yx1, y2, y1 is the left endpoint of some horizontal segment. Yes, this is one of the very. Oh, and I don't have to provide this, just this one. The rightmost begins. Any ground between the leftmost and rightmost building should be part of the skyline's contour. There must not be consecutive horizontal lines of equal height. For example, this is not allowed because it's not acceptable. It should be all 5, so you should only have 4. Yeah. don't remember how this one's solved though. I remember I tried to do this with a very convoluted method, but it didn't work. So I checked the solution. And Lord, I have no recollection at all. How would you solve it now? Well, so we can sort the buildings by their x-coordinates. Okay, let's start. And then for each x-coordinate, man. How about we, I don't know, I literally have no idea. I forgot, and I don't want to get into it again. Because I remember last time was a very long struggle. I'm justifying too. My God, what a time! Oh, this is terrible. And it just shows, but it didn't give me a summary. Can I switch to the old one? That's what I want. I want this kind of show me. Yeah, it was a very, very long time. That's why I don't want to get back into it. A discussion. Oh, they put discussion. They put that into solutions? Nah, this is terrible. Yeah, I like this one. I like this kind of feel. Anyway, what I'm thinking is maybe we can go top to bottom. And each time I try to see if there's any starts. How would you solve this? So the tallest building, because it's going to be like this, right? And each horizontal line is due to some building's top. So at each building's top, we just want to ask a question, whether a portion of this top is covered or is uncovered. And how do you know? I mean, the tallest one definitely it's not covered, so we can get this point, right? And then we get to this, and when we get to this, we see is this, right? This is what we see. And Now I need to know who blocks it. Well, the only thing that can block it is the one that's taller than it, right? So I just want to ask the question, is there any intersection between the tallest building and this one? And I think in this case, yes, there is an intersection. So depending on how the intersection happens, so this is here, so this intersection happens this way, so that's why it's gonna be here. And on the other side, there's no intersection because this is the tallest building. Okay, now we go to this height, right? And this height, we have two taller buildings, so they can intersect, right? And how do they intersect? Well, I mean, it can be combined, right? We can merge their intervals, and their intervals merge into this. And then we consider this one and this. And after that, we merge the interval. And then this one doesn't. So we have interval of this and the interval of this. So we have two intervals now, right? So the next one's here. You think it's going to work? It's going to be O(n) squared because the number of intervals is going to be huge. But when we get the intervals, what we have is going to be, left, right. We're going to have a left, we're going to have a right. And I believe we can binary search that, right? So like we have a left, a right, and left, a right. And then the new thing come in, we have the left, and we simply just binary search this left. So that will be log n. This method might work, but let me double check. Let me double check something. Like I say a equals, okay, let's say a equals 1, 2, 3, 5, I don't know, 4. Actually, this is not happening. 1, 2, 3, 5, can now be 4, 7, 8, right? Can I do bisect left, let's say a and, I don't know, 6, 7. Is this possible? It is possible. We can. So we put this position. Let's try. All right. All right, so what do we need in this case? Now we have buildings, right? So we need to sort the buildings by their height. And I don't really care about, what if they're the same height? Let's say we sort them by their heights, right? And then, do we also sort? It's not necessary. We don't have to sort. So we get the first one out, and then get a second one, and we compare to the previous one. If it's the same, then we try to see, if it's the same, if they overlap, then you don't record a new one. So each time, right? Each time we get a new building, we merge it with the previous. We merge it with a previous interval, right? And when we merge it, we will know the location, the point, and then we see if they have the same height. Same height. This interval Well, let me think again. So, because the interval has different heights. That's the thing, it has a different height. And if the current, let's imagine this blue block is the same height as the green and occur on the right side, right? And then it is very easy for me to find out this is the previous interval, and now we have this interval, and they merge, right? And we know the new point is here. But how do I know that at this point the height is the same as this one? See, that is the question. Well, because we go high to low, right? So when we hit an interval, the height is either this or this, right? It cannot be another, it won't be something in between, okay? So if it's not going to be something in between, and we have this boundary, right? So we have this boundary, and everything inside this boundary is higher or equal to me. So all I need to know is I get two values, right? We need to know the height on the left bound, and we need to know the height on the right bound. For example, this thing, if this rectangle, if I fit here, right, it either sticking out here or sticking out here. If it's in the center, it's just completely gone. So it's either here or it's either here, right? And if it's here, I just need to know the height of this one, because if they are the same, then I will extend this, then this one will disappear. If they're the same, then I don't record, right? So I just need to know the left height and the right height. So it's more than, so I need to have a tuple of 4 values. The left, the right, right, the left, right, and left height and right height. So 4 values. So here's where we're going to go. So first of all, we're going to sort this. We're going to sort based on 2. And we're going to reverse. All right? So we're going to do this. We sort it, reverse. So the tallest building go first. And then we are going to produce a interval. Damn. Maybe it'll be easier to use a dictionary. We use the left as the key, and the value will be right, the left height and the right height. Okay? And and each time you sort it each time? Like if we want to insert one in between, what do we do? So we want to keep the whole thing sorted. Yeah, how do you keep the whole thing sorted if you want to binary search it? I feel like I had this problem before, and every time I forgot what's the solution for this. If you want to keep a list sorted as you, if we merge, then that's okay, right? Because that's the left bound. Oh, if it's the left bound for what if my building is very fat? Then you remove, right? Then you remove. You can remove. What if we want to insert something in the middle? How do we prevent that? What if when we sort, we also sort from left to right on the left bound? Man, it doesn't really work because, yeah, it doesn't really work because the first one is the top. And I'll be O squared log n because you have to just sort every time. I don't think that is wise. Yeah, I want to append some value and also keep the list sorted. We can use sorted list for that, but I don't think that is the solution though. Oh, I remember bisect has something. Hey, you know what? Maybe we just try it. I mean, it's fine. It's okay. But no, it's not okay. We have to use a dictionary because we might remove some boundary. Like if I have a very fat, right? I have a fat building and then it hits something and then you'll remove. Yeah, it'll remove some boundaries. Yeah. Code it up, right? If it fails, we check the solution. So we're just gonna sort from top to bottom and we're gonna have a boundaries, left bounds, okay? That's gonna be a dictionary. And then what we're gonna do is go one by one. We say for buildings, right? For buildings we have LRH, LRH in buildings, right? We get the results every single time. And at the end, we just sort them, the results. What about this thing? Well, at the end, at the end, we always add the last one. So we have the boundaries, the last boundary, and any intermediate boundaries. Yeah, we can add the last one, doesn't matter. So we have the result, right? Yeah, we need a height as well. Okay, so with left, right, and height, so what do? We will see if there's any bounds. Right? We just say if there's no bounds, we can save that by go through. We actually say left bound, right? The L, I choose buildings 0, 0, right? So this is the left bound. That's what I want to record, and we're gonna have some values, which is the right bound, buildings 0, 1, right bound, and the left height and the right height, which is buildings 0, 2, this is the left height, and buildings 0, 2, right height. This is the same. Right, so let's say each element, the values are right bound, left height, right height. And now I can go from 1 to the end. So I'm going to save an if-else check, right? So, oh, and this one will be left bound. So we'll have this and this. That's definitely in there, which is the top building. Tallest. Oh, in that case, we might want to solve. Yeah, we have to go left first. So let's do this and list 0. Sort by both. So if it's the same, the leftmost pop up. So I can do this, which is fine. Okay, so this is done. So for the new one coming out, I need to first sort. Right, I'm gonna say sorted left equals sorted. Oh, I'll have to do this every single time. Left bounds, right? And then we say index equals bisect I like to use bisect right. Sorted left and the current left, right? Okay, so now we sort, right? We've done the sort. So now we can see if, so the possibility is we get to some value, right? And so we have the previous bound, some, and then if it's in between, if the new thing is in between, then you need to consider it's going to be in between, or it could be equal to some left bound. Yeah, I don't see how it's going to be different. It will be different if it's equal. Well, we can say if it's equal. Alright, the easiest case is this is the new one. Nothing's on the right. Is that the easiest case? Yeah, that shall be the easiest case. Okay, so we say if index is equal to len sorted. So that's the last one. Nothing between. And also it could be the first one, right? It could be the first one. Yeah. So it's in front of the current one. In front of the current one. So we deal with these two first. So if it's the last one, right? It's the last one. Now we need to see how it compares to the previous one, right? Then we say the previous one is going to be sorted left, index minus 1. Right? So that's the previous left bound. Then we go left bounds. This, what's this? This is those 3, right? Then we have the right bound, the left height, and the right height, right, of the previous. This is the previous, so the previous, and the previous. Then we say if the previous right bound, if it's smaller than, right, if it's smaller than the current left bound, and the current left bound is a completely new thing, right? The current left bound is a completely new thing. So if that is the case, right, if that is the case, then we say and it's also at the end, so it's a completely new thing. So we need to say res.append right? The current, left, and the height, and left bounds, left shall equal to current and right bound, left height and right height. So this is a completely new thing. So that's that. Else, right? If the previous right is larger, so we either we touch, right? Then or it gets eaten, right? It gets eaten. So in that case, what do we say? Well, in that case, we will see if the previous right height, if it's equal to the current height. So they merge together. So in that case, the result don't change, and we'll change left bounds. Left bounds. This, we probably should do previous left equals this thing. All right, this is the previous left, and the left bounds previous left, right? And basically change the boundary, and the 0 shall equal to the current right bound, but the height are exactly the same. So that's that. Else, that means the previous right height is bigger than the current height, right? Because we sorted, that's the only possibility. So the previous height is bigger than the current height, and it kind of eaten into it. So if that's the case, right? If that's the case, then result, we can append a value. But it's not the left, it shall be the right, the previous right, right? Because they eat into it, so the previous right, so we're talking about this situation, right? This situation, so previous right and a current height. Previous right and a current height. And then we change this as well, because, so we change this into and, we're going to change two things. And we need to change the right height. So 0, 1, and 2, right? This is the right height shall be the current height. And this will happen no matter what. So we put in here, and then we just say if this is larger than, then we do this. Okay, that's it. That's the situation. If index is equal to 0. If index is 0, so it means my left bound is the first one, right? It's the first one, because we do bisect right, so if it's the same, it becomes the next one. So it's the first one. It's in front of everybody else. So if that is the case, right, we have some left bound behind me, and I am the first one. I am the first one. So what I shall do, right, immediately is to see if I touch anybody. So here it is. So previous next, so we're going to say next left shall equal to the current sorted left 0. This is the next, right? So next to left. And then next to right, next left height, next to right height shall equal to left bounds, next to left. Okay? So now we say if the right, current right is smaller than next to left, right? If that is the case, right? If my right is smaller than next left, if that's the case, then I'm completely independent. Okay? I'm completely independent. So what does that mean? That means result dot append my left and height and left bounds, left equals right h and h. Boom, that's that. Else, my right. So that now is interesting. So my right might extend all the way down. Okay. Ooh, how are we going to deal with that? It could be a very, very fat one. And we have to go through the entire thing. Damn, man. Seriously? No, this doesn't seem right. It can't be. Okay, here, my right is going to be extending because it might extend beyond 1, right? Or beyond 2, or beyond 3. I need... So I have the left bounds, right? And it's guaranteed. Each left bound is also associated with a right bound. So I can binary search that as well. But to do that, I need to create a list of right bounds. And to create that as on. So it's already on. Holy crap. But we're already very deep, so let's just do this. So what do we say? So we say for everything in the sorted left, right? 1 by 1, everything in the sorted left. And for each one, we will check, right? We will check it's right. If it's right, then we shall remove it from the dictionary. So we say for left and sorted left and SL and sorted left, right, for every single one, right? For every single one. I feel like this also applies. Let me think. Because this one also applies when we're not the first one. So I think we might be able to kill 2 birds with 1 stone. So we just need to analyze on the left. Yeah, we just need to analyze on the left. Ooh, the left. Man. Hold on, let me think again. Yeah. It will annihilate those. Maybe I can write a function for this. So I just need to, I think it's easier to do it this way. I'll do it, I'll still do it this way. So for sorted left and sorted left, right? So for every single one of them, I need to check whether my right extends beyond. Right? Is it checked for the left? Like if it's, yeah, we need to check if it's extending beyond Yeah, if my right is bigger than your left, but that didn't mean anything. But if my right is beyond your right, that means you're gone, right? And we just say if left bounds SL 0, right? If it's smaller or equal to my right, right? If it's smaller or equal to my right, then I'm removing you, right? I'm removing you. How do I remove you? If you're smaller than my right, then I just say, I can just delete, right? I delete left bounds SL. I just remove you because it's not necessary until a point where this is not true, right? So if the first, so otherwise, I'm going to break. Okay. So let's say if the first one, it breaks out. Okay. So for something that breaks out, then I need to check whether my right is larger than its left, right? Current SL. Current SL. Yeah, this is not necessary. I can just do this. I don't even need this. When you break out, I could just wipe out the entire thing. So I can say else. Else is it's just, it rolls through everything, right? If it rolls through everything, then we delete everything in left bounds, right? Delete everything in left bounds. So in that case, you know what? I think this will always hold because I'm the first one, right? Regardless. Oh, hold on. Well, yeah, it's because I sorted that way. Yeah, because this will definitely be shorter. So yeah, if I am the first one, this will definitely happen regardless. This will happen regardless. And this will be fine. And this, I just removed everything from the left bounds, right? Then I just say left bounds, left equals RHH. That's that. And continue. Which is go to the next one. Otherwise, which is break out, right? If it breaks out, that means if it breaks out, that means some left bound's right is larger than R. Okay, so we break out. So now we have to check my right and this SL. We say if my right is smaller than SSL. Okay? If my right is smaller than SSL, then we say ooh, that is not right. If it's equal to, it's different. Hold on. If it's smaller, if your right is smaller than me, then yeah, we definitely delete you. You're useless, right? You're useless. Else breakout. Else breakout. And then we have a content. Is this or in middle or is the same? So if R is smaller than SL, R is smaller than the SL. Now in that case, and because if it's equal to, oh, probably we should first check if it's equal to. Yeah, let me check if it's equal to. But if R is equal to, hold on. So if this is smaller, then we just remove it. Then we check the next one, right? So for the next one, it could be smaller, or it could be equal. So if it's smaller, than SL, that means smaller. Otherwise, if it's equal to SL, yeah, smaller than SL, equal to SL, in between, or there, I'll have different conditions. So if it's smaller than SL, then we establish new things. Say left bounds equals is right, yeah, HH. Well, if it's equal to SL, so we're touching. If we're touching, then left bounds L shall equal to left bounds SL0 H and left bounds 2. The height is going to be that one. And then we delete this. Aleph is larger than SL. If it's larger than SL, right, then, or up until it touches the right. So in that case, so I just say else. In that case, oh, that case is the same as this one. Because start when touching, I'll keep going, that's the same thing. So I can just else here. Yeah. I'll just say the left bounds L extend all the way to left bounds SL0. Extend all the way there. And the height, right height is going to be this, left height is going to be this. And I'll delete this one. Okay. maybe it'll be easier to say for I. No, it won't know. Yeah, this is fine. So that's that. Else. Okay, what's this else? This else is its index is inside somewhere. Okay. Then we can produce the left one. Right? So I have something in front. And how do we argue this? Well, the way we argue is if its right is smaller than my left, then I establish. Right? Otherwise I don't establish because I got smothered in. So I don't establish. Then we consider the right, which is the same as this one. Right? It's the same as this one. Let's see. Maybe I can write this into a function. I just need the index. Right? Let me see if we can write this into a function. Resolve right. When it passes sorted left and left bounds and an index, the starting index for sorted left. And when I return, you don't have to return anything. I don't have to return anything. Alright, so what do we do? So we're just going to say, oh, and I need the right. The right HH. I'm just putting this here. We need an index and we need a right height and all this. And then I'm going to say while index is smaller than len, sorted left, right? And then we say SL shall equal to sorted left index, and if this is smaller than this, we remove it. And blah blah blah. Once we're done, and also whatever we say index plus equal 1, right? So once we're done, we say if index is equal to len sorted left or my right is smaller than sorted left index. So in these two situations, it's going to be this, right? So we're just going right. But do we do the left bounds? That's specific if we have a left, right? That's specific if we have a left. I'm going to say shall establish new left. Yeah, if I shall establish a new left, or if I don't, should not. So radish index, and then the affected left. Okay, so this shall be the affected left, because we don't know which left it is. This is also affected left. Okay, so if r, the right is smaller than this, then we say the left bounds affected left equals r, h and h. That's I don't think this is a good idea. I think it's actually make it more complicated. Rather, because the two situations are not the same. Yeah, so I just do it here. Same as before, but with a slight twist. Okay? So index, so I can just say I, right? We just set up an I. I say I equals 1, right? Because index is 0. So when you say while I is smaller than this, it's going to be this, right? And then on the delete, and I plus equal 1. I say if I is equal to 2, which means I deleted everything, and r is smaller than this I, the left, I is smaller than this i's left, then I will establish the new one. Otherwise, it's going to be else we can say s left equals sorted left I, right? This just means r is larger than the sorted left I, but it's smaller you go to the current r. So I would say left bound, we start from L, and the right will be its right, and the left height is h, and it would be its right, and I delete it. Perfect. Okay, I agree with this. So else, right? In this else situation, we need to know whether we should establish, right? So how do we know whether we should establish? We say if my left is larger than, can I just say previous left shall be sorted left index minus 1, right? So if it's if my left is larger than left bounds pre-left 0, if I'm larger than that, right, I'm larger than that, than the right of the previous, and in that case, shall establish, right? We shall establish. Then I say the current left shall equal to L. Else current left is PL. So when you say current left is equal to L if this, else PL. So the current left, right? So we have the current left, and you just do that, right? So the left doesn't matter. So either I create a new one, or I just change that, right? It's totally fine. And then I start to see, oh, hold on. We also have a situation where it didn't. So we have to start from the current left, which is index -1. If I go out, okay, so that should be a separate situation, right? Previous left. Okay, that's the previous left and my current right. If my current left, or if my current right is smaller, then there's no consideration, right? If my current right is smaller than its right, then we just continue. If it's larger, then we're talking, right? So we're gonna say if my current right is smaller or equal to left bounds previous left and 0, then we just continue. Don't do anything. No, because you're inside, the right is inside, the left is this, so the entire thing is contained within the previous, so there's nothing. So now we establish now the current right is larger than, right? Then we have the current left, determine if we created a new one, and it will never delete the previous one, right? Then we can say I shall equal to index. We start from the next one. And then while I is smaller than len, sorted left, SL equal to sorted I, and say if left bounds SL 0 is smaller than R, and we can delete it. Left bounds SL. Right? And then I plus equal 1. Coming out, so this is the same. Right? Coming out, we say if I is equal to, which means I extend all the way down, or so L is larger than this, then we establish a new one. If it's here, then ooh, yeah, this is a we have to consider this separately. Okay, so R extend all the way to the end, right? Then we say if my left is larger than, then boom, that's the one, right? It's larger than previous left to right. Then I establish a new left, and then it's going to be my right is my right. Else, then left bounds previous left. Then we're going to change some stuff. Previous left, now the right is going to change because the right is going to be here. Another thing to change is the left, right. The right height shall be my height. Right, that's that. And in that case, I need to add a result. Right, I need to append because I am a new one. Right, I am a new one. So I shall append my left and my height because I'm a new one. In this case, I'm not a new one. I got smuggled by the previous one, higher than me. Oh, higher than me. It could be this case again. Alright, so if I'm larger, I definitely do this, right? If I'm smaller or equal to, this is update the left bounds, which is correct, because the left should still be this. Left height doesn't change, but the right height, right height change. And we shall say if, oh, I should change it beforehand, right? Because I extend inside. And I should say if h, my height, is not equal to, right, smaller, not equal to, left bounds PL to its right height, right? If my height is not equal to, then res.append left bounds PL 0, right, and my height. But if it's equal, then I got smothered, and then I update the two. Okay, so that's that situation. And else, right? Else means at a certain I, my right, so it would be the same. So we can still say SL equal to sorted left I, right? And then we have to consider exactly the same thing, right? We have to consider, so basically we have my right is smaller than that, right? My right is smaller than that. So if my right is smaller than that, yeah, if this one is smaller, then we just delete. But now I am smaller, right? And have you considered the situation? Oh, I considered R smaller than this. But now R is in between, right? Now R is in between. So if it's in between that one, there's a possibility of touching, right? There's a possibility of touching. Oh, I think I forgot to consider something here. I want to extend all the way right. I'll come back to that later. What's this? No, hold on. Previous right is smaller, then we do the whole thing, right? We do the whole thing. Otherwise, we have the previous left to right become right, and then we add, this is right, this is correct. Now in this case, if I'm in the front, I definitely add this. And then I say if R is smaller than this, then we add this. Yes. Otherwise, shouldn't be there 0? Yeah, this should be start from 0. And then I have this, right? And I check this R. If my right is larger than this, then I remove it. But then I will generate, then I'll generate a new, holy crap, for each time I remove, wait, hold on. We have this bound, right? And I'm here. There's something lower, and I cover it entirely. And I have, then shouldn't we have, no, we don't count this one. Yeah, so we cut it through. But if we exit, we need to count the exit point. So we say so we have the exit point, so we need to add this if it's smaller, for sure. So we say whenever this is cell 0, it's right, it's smaller than me, then we say if it's smaller or equal to, then there's no change. But if it's smaller than me, so I'm sticking out, then the sticking out part, then we should say if left bounds SL012 is larger than my age, then rest need to append, right? Rest need to append something, which is this, right? And my height, because I stick out, it's going to be my height. And after that, we remove it. So every time we remove it, we need to add a point. Remove it and to add a point. Until a point that we don't do anymore. So we go within, and then we say, if there's no more, I removed everything, right? If I removed everything, then the last time I remove, I also put this. Then I just do this, which is perfectly fine, right? Otherwise, if I'm in between, then when I enter that one, we don't have a record. We'll record it previously. So all I need to do is change my right bound, change this, the right bound to this, and remove this. Perfectly fine. So in this one, I have my left, right? My left is in here. So if my right is smaller than the previous left's right, then it's definitely just in between. Then we remove everything. Otherwise, we start from index. Should be index -1. Right? I think it should be index -1. The first one is to consider. And then we have this, and we have its right. If its right is smaller than, you shouldn't delete it. No, because I already considered, so it's already sticking out. Yeah, no matter what, it's already sticking out. Okay? It's already sticking out, and we start from this one. And if some of it's, and then I have to do the same thing here. I have to add this, right? Which basically says if this thing, the right is smaller than me, but if its height is larger than me, then we need to add a new result, and then I remove it until the point where this, so I'm sticking out all the way. And then I say if my left is larger than this R, right? If it's here, then I establish my own. And we also append my own, yes. Otherwise it means I'm inside, right? Otherwise I'm inside. And if I'm inside, and we can say this, if this is larger than an H, then I have to add this thing, which I think shall be considered no matter what, right? Yeah, I feel like this shall be considered earlier. Right? Because if my left bound is larger than PL0, then regardless, result need to append my left bound in H, regardless. If I'm larger, they have to append. If I'm smaller, right? If I'm smaller, so right now it extends out. So if I'm smaller, which means else, if I'm smaller equal, then we need to add, rest need to append left bounds PL 0 and H, right? It's a new thing. The new thing come. L actually should be elif left bounds PL 2 if its height is larger than my height. Then if it's not, then we don't do anything. So we handle those. Then we come in here. Then all we do is to establish the left bounds, right? So we say if L is larger than, then we need to add the left bound. If else, then I have to do this because I already done it. Then basically we just say this thing's right bound changes and its right height changes. Else, right? Else, so we find something whom my right is smaller or equal to, right? And it could be and then we have to do the comparison. Why I didn't do the comparison here? Because the right, it could land. Oh well, I already handled this thing. Right, I already handled this thing. So in the current case, it's smaller, so it's either here or here, right? Either here or here. So if it's here, and if it's here, yeah, I have to do one more check here. We say if R is smaller than SL, right? Then it's in between. Then we say left bounds L yeah, because the right is in between. right, change, else. Here the same. We should say if R is smaller than SL, right? Then depends. Then I need a current left, right? Which is current left shall equal to left if left is larger than left bounds PL0. So we'll establish a new one. Right, we'll establish a new one. Else PL. Actually, you know what? I don't like to do it this way. So we say if R, right, is smaller than SL, right, so current is smaller than N, and then we say if left is larger than that, then I cover the entire thing, right? I cover the entire thing. So we say left bounds L shall equal to right H and H. And do in the past, else then left bounds PL, right? 0 shall equal to R because they extend to R, and left bounds PL1 shall equal to H. Else, if R is larger equal to SL, so we merge into this, right? Again, we shall do this. If L is larger than this, then left bound L equals the right bound is not this. The right bound is left bounds SL 0. Left height is H, but the right height is left bounds SL 2. So, oh, it should be 2, not 1. So it'll be the same as this one. Yes, and of course we'll delete it because it's useless anymore. Else, else means I merged. So I merged. Oh, so regardless, this one's gonna be deleted. Then shall be left bounds SL0. It's right. And left bounds SL2. And I'll delete this. Then go back to the next one. I am 100% sure this is not going to be right. So this is my logic. Alright. So once we're done, okay, we have to go through the left bounds again and then pick up all the right ends. Right? So we should go, let's say, for basically just a vowel and right, we don't need these two, in left bounds dot values, rest dot append, and those are zeros, right? Dot append are 0. So we're picking up this and this. And then now we can return sorted res. All right. I mean, why bother? You know it's not gonna work. But it's good just to go through this thing. If it doesn't work, then it just doesn't work. No hard feelings. This is a very tough one. I remember last time 3 hours, still couldn't dent it. And today, I don't plan to spend that much time. So we'll see. Like I said, if it's not right, I'm not gonna just get stuck here. Get skyline. Fail. Answer. Oh, I got 2. Let's check the first one. 210, 315, 7, 9. I get a 9, 0. 12, 15, 20. I get a 9, 0. What the hell is 9, 9, 0? Nine zero. You shouldn't be there, man. You shouldn't be there. So this is the first one, second one. This is the third one, right? The third one. I should have this, and this coming in. It's contained within. How do we have the 9 coming here? Okay, how do we debug this? Well, we print the current state. Right, so it's in a for loop, and we just print our state is left bounds is our state, and we just left bound and the left, right, and height, and we'll see how it goes. All right, let's see. First one we do. Let me sort this. It doesn't matter. I know. First one is this one. 5, 12, 12. Oh, the highest point is 12? No. Oh, I already done 12. My bad. The first one is this is the first one. 5 to 12, because I already have. And after that, I say start 3. Left is, right is 12. Left is 15, right is 12. That is correct. Okay? So next one is 15, 20, 10. 15, 20, 10. Why? Why? It should be this one, the next one. Did I sort it wrong? Yeah, I say I sort it based on height, and then based on, wait, this is ridiculous. Oh, shoot. I shall do negative. There we go. 2, 9, 10 comes first. All right, so 2, 9, 10 comes. Okay, so we have no. 3 needs to be deleted. it should be from here to here. Should be from 2, and this is, hold on, this is not right. So we have, start with 3, right, 12, so 3, and then 2, 9, 10 comes, okay? So sorted is just 3. And binary as such, so we go to 0. Index is going to be 0. So we're going to append LH, that's fine. So the right now is 9. Is smaller than the left? No. So we say I equals 0. So we start from here, right? I equals 0. SL, so SL is equal to 3. So its bound is smaller? No. Oh. I see the problem. Shoot. What do we do? What do we do? I need a sentinel. Wait, you're supposed to break. I forgot to break. You're supposed to break. If you see the first one, then you should break out. And then I need a sentinel. Some are bigger. Yeah, in that case, I don't see why you need to do it this way then. Like, seriously. Some R is bigger is false. Until here, some R bigger is true. Right, and we break out. Then we're going to say for SL in sorted left. Don't have to do this. And then blah 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 blah. We don't have to do this. We don't need I. And then we just say if some R is bigger, it's true. If not, some are bigger. Which means we just go through the entire thing. We never hit this, right? If not, every R is smaller, then we do this. Else, then we hit some R is bigger. This SL is bigger. So we say this and this. Okay, so now in this we shall do the same thing. Index. Well, this one we need to do index, which is fine. But we still need some are bigger is false. And then here we should say else. Some are bigger become true, and I'll break out. Okay. So I want to break out. I points to some are as bigger. So we say if not, some are bigger. We probably need, hold on, I have two conditions. Yeah, two conditions. This is some, if not, some are bigger. Yeah, I think if not, some are bigger, or you're right. Wait, isn't these two the same thing? Hold on. Yeah, you're repeating. You see that? You're repeating. If summa is bigger as false, so I'm leading all the way to, yeah. If my R is smaller than the SL, then in this case, so I already consider this, right? So I don't have to do this. These are the same thing. So I don't need to do this. And here the same. If not and R is smaller than, then we do, let's see, these two are exactly the same. Sorted, If this is smaller, and then say if the larger than this, we do this, so I don't need to do this. And of course there's no else. Right, so R is larger than this I. Okay, now we pass this one. Both pass. Yeah, we're just gonna throw it. It might pass, it might not. Who knows, right? This type of thing, who knows? Got a wrong answer. Yeah, screw it. I'm not gonna waste time on this. I can't do it. Input, output. You know, this is such a simple test case, so maybe I should. Take a look. Yeah, I'm about to give up. Oh, you already see the problem. What the hell? 2, 1, 2, 2? 2, 0? Come on. Alright, so what we have? We have 1, 0, 1, 2, 0, 1. So 1, 2, 1. 1, 2. Oh, 1, 2, 2. 1, 2, 3. Should be 1, 3, and 2, 0. Yeah. Oh, let's see. How do we do here? So the first one we hit is 1, 2, 3, right? So we have 1 to 2 is 3. And hold a second. So 1 to 2, right? 1 to 2 come, which goes with what situation? So 1, 1 should be this, right? And if R is smaller or equal to, shouldn't we continue? Yeah, shouldn't we continue? I consider this case. I specifically consider this case. PL0 is 2, right? Your R is also 2. Right is also 2. You shall continue. What the hell? Alright, I need the R index. I didn't hit here. Oh, I hit this one. God damn. Oopsie doozy. Yeah. Well, seems like what we need to do is if this, then this, and right, and left must be larger than sorted left index minus 1, right? Otherwise, here, if it's the same, it has to be larger than, and 0 is a different case. Okay. Yeah, I don't even go through these. All right, try it again. Simple cases, I think I'll just try. Oof. I think it's the same problem. I have exactly the same problem. All right, dumbass. What's now? 1, 2, 1, 1, 2, 2, 1, 2, 3. 2, 3, 1, 2, 3, 2, and 2, 3, 3. All right. Alrighty, let's see. What the hell? The first one is going to be 1. So the next one comes in at 2, 3, 3. 2, 3, 3. So we have 1, 3, 3. That is correct. What the hell is this? A right height. Right height decreases. What the hell? So anyway, it's going to be this, right? So now 2 comes in. Okay? 2 comes in. Oh, Lord. That is absolutely correct. 2 comes in, has have to have more. The left has to be larger than, no, left. Yeah, we want to be the last one. Left has to be larger than, left bounds. We're handling this right most, the rightmost. The left bounds this 0 has to be larger than the, because we are at the end and we want to know if I am. See that? So we have to be the real end, right? The end. Okay, so I think the only thing changes here. I didn't do anything else. Okay, so I go here. So instead of this, we do this. Oh! Huh. It passed! It freaking passed! Oh, you have no idea how happy this made me. Oh my god, it passed! Oh! The analysis The analysis, yeah, that was a little bit lapse. I could have passed in the first try. It's just here is a little bit, yeah. Oh, wow. It freaking passed. But so complex. So complex. See you next month. Oh, wow. Oh, wow. An hour 45 minutes. I think we improved. Last time, from the first one to the last, like I gave up after 3 hours, right? And 2.5 hours, I gave up. And I checked the results. And this time, it's an hour 45. That's improvement. Oh, how should I say this? Wow. Okay, it's very convoluted. Right, so just pure analysis. Wow, oh my god. Oh my god. Finally something good happened today, huh? Something good. Alright. This is 2.128. Maybe I solved it myself last time. I don't know. I have to check both solutions. And of course check my solution today. My god. I did it by myself. Could have passed on the first try, but got a little confused about the first if condition. It was fixed very quickly. So this solution is pure analysis. We sort the buildings in reverse style, in descent, right? For heights, and if heights are the same, sort left ascent. Then for each building, then we build, right? Then we build the range for each contour. We use the left bound as key, and the value is right bound, left height, and a right height. For each new building, we sort the keys so that we can use binary search to see where the new building shall be placed. And since the height of the new building is not higher than all the existing contours, anytime the new building has left side stick out, left or right side stuck out, we record the results. Also, if the new building, right, touches or merges with some of the existing contour, we update the contour or delete them, or delete it. it's convoluted, but it can be done, right? It can be done if one is patient enough. All right. Damn, man. So this is gave up. Oh, look at this. I'll go for the next one. Okay, I can post this. It was pure analysis. Pure analysis. Yeah, I don't post it just for fun. Why? Nobody gonna learn anything from this. 40 test cases. 36 test cases. Maybe because I got really fast. Maybe. I'm gonna make it funny. Alright, so this is pure torture. Okay. This is not an elegant solution. It's extremely convoluted. And it requires pure analysis. Almost cruel and unusual. I felt despair as I coded up. I didn't give up solely because I had invested so much time in it. A lot. but didn't give up. That said, it is surprisingly fast. So I'll just leave it here for the lols. I can put the link. Yep, let's do this for fun. Wait, where's the syntax highlighting? Oh, Python. Alright, I will not bore you guys. I will have to check the solution, but that will be it for today. I'll see you guys tomorrow. Adios.